Alrighty. We kind of started this one yesterday, but we had a couple of requests that we start this one again, which is actually good timing as Maddie walks in. So, does she still have a leg, or? For the moment. So we're looking at example 2. We're doing this one again. We started it yesterday, but there was a few questions about it, so thought it probably best to start again. So for those of you who weren't here yesterday, for some dramatic reason, we'll actually... This one will be going up online, so you'll be able to follow it. But we're basically talking about the locus being a path that obeys certain conditions from a point. So we talked about finding the equation of a locus of a point, xy, that moves so that it's always 3 units from the origin. And so when you think about that, if there's the origin and it's always 3 units from it, what's the shape it's going to be? Yeah, it's going to be a circle. So that's the first thing we went, okay, it's a circle, its center is 0, 0, and its radius is 3. Then we looked at the circle formula. We were able to just do it. The other way we could do it was by using the distance formula. And the reason I'm talking about this particular question is because I want you to think about the distance formula. So d squared equals all that, x squared, x2 minus x1 all squared, plus, minus, that should be a plus. How come no one picked me up on that? Oh wow, that's working like an eraser. There we go, should be plus, yeah. X2 minus x1 all squared plus y2 minus y1 all squared. That's the distance formula, which actually we did over here. Put p anywhere on there, and we know that the radius is 3. So what we did was x2 minus x1, so we got x minus 0 plus y minus 0, and they're all squared. So you end up with that equation which we came up with by knowing it was a circle with center 0, radius 3. So 2 ways of doing it. Does that make sense? But the point is, to do that, we used the distance formula. You'll notice I've actually got written down here the distance formula. I just didn't put the d squared. Cool? Okay, I'll put it in now just so that we know it. D squared equals. So that's the distance formula. The reason I put that down is because we're going to use it. Now, this question is a little bit more complicated in the way it's written than the previous question, and therefore it starts to look a bit more complicated when we do it, and that was one of the issues and why we had to redo it. So we're going to step through it again and see if we're happy with it. I don't want to update that, but thanks for asking. All right, so it says find the equation of the locus of the point P that moves so that distance PA to distance PB is in the ratio 2 to 1, where A is minus 3, 1, and B is 2, minus 2. So the first thing we're going to do is we're going to plot those points. Okay? Going to plot those points. I've already got my red pen. So the first point is A, minus 3, 1. So I'll put that there and call it A. And B is at 2, minus 2. Which is there, we'll call it B. Now what we know is that there is a point P such that the distance PA is twice the distance PB. Does that make sense? The ratio is 2 to 1. So PA is twice as big as PB. So arbitrarily, we can put it pretty much anywhere. I'm just going to put it here for now. And I'm going to call that P. XY, and I'm going to draw a line between there and there. And now we look at that, and PA looks about twice as long as PB. Is that all right? Why in that particular spot, or why did I put it there at all? I could have put it anywhere that it would look twice. I just chose that spot because it's nice and compact. I could have actually put it there, because that's about double that. It doesn't really matter. And in fact, if that PA, like if I'd done it there, and if that is twice as big as that one, then that is one of the points that would exist for this condition. Does that make sense? So you got to remember, I'm just picking up point. When we did the circular one, when we did the previous one, you picked, like, there's the center, and the locus is that shape, right? I could have put the point there, or there, or there, or there, anywhere. An infinite amount of possibilities on that point, because all of them satisfy the condition that it is 3 units away from the origin. That make sense? So, yeah, that's just an arbitrary spot I just chose. Cool? All right, so, yeah, so that point P is just an arbitrary point. Cool? All right, so now what are we actually trying to do? We're trying to find the equation of that shape, whatever that shape is going to be, or the equation of the path. I shouldn't call it a shape, I should call it a path. Okay? So what are we going to do? Anyone got any ideas? Because this is the sort of thing you need to know how to attack. How do I attack this? Now, I've given you a hint by putting up the distance formula. Good assumption. We are probably going to use the distance formula. What do we need, realistically, to get an equation? What do we need it to look like? What are the things we need in an equation? Sorry? An equal sign? Yes, because that is the definition of equal equation. Excellent. We need an x and a y. See, we've got an x and a y in here because we've got a point, xy. So we need an x and a y, because the whole thing is, remember, with these loci, when you do them, you're talking about a relationship, and to have a relationship, you've got an x and a y, because the x and the y are related to each other. Yeah? Okay, so the question is, how are we going to do it? Well, what do we know? What does the question tell us? What is some of the stuff that it tells us? Cool. Well, let's do it with the ratio to start off with. We know that PA to PB is 2 to 1. Cool? And once again, ratios are lovely, but let's write it as a fraction so it's a bit more manageable for us. So I'll convert that to a fraction. So PA over PB equals 2 over 1. Is everyone happy with that? I haven't really done anything. But one of the things, whenever you're solving an equation, especially when it's got 2 variables, you need to get rid of one of them, yeah? So you can actually solve it. So what I'm going to do is I'm going to rewrite PA as it relates to PB. Now, this is something that Catherine actually said, and I took 3 steps to do it. Okay? PA is twice as big as PB. Okay? So PB times 2 will give you PA. That make sense? Excellent. We've now got a relationship that's nice and easy to handle. Cool? Now, how am I going to use that? What is PA? Sorry? No, but what is it? A is the point. What is PA? PA is the distance between P and A. The distance. Yeah? What is PB? The distance between P and B. Yeah? So we now know, because we've done this from what the question gave us, that the distance between P and A is twice the distance between P and B. Cool? So all we're doing really is reframing the question so we've got it in something we can do. Now we have a distance formula that involves x's and y's. Pause. What do you mean I'm a set? That's harsh. Huh? She's short. Shorter than me. If you're shorter than me, you're a short person. Notice how I haven't had at this school, I haven't had fat person, because no one's fatter. Just saying. All right. So we know that the distance between P and A is twice the distance between P and B. Everyone happy with that? Cool. So now we're thinking distance, we can start thinking of distance formula. Yeah? So if I started going, well, I could chuck in, x and y coordinates in here, because I've got x and y coordinates for these. Okay? A is at minus 3, 1. B is at 2, minus 2. So I've got coordinates. And I've got x's and y's. I'm starting to be able to use these to create an equation. Everyone happy with that? Okay, so I can use distance formula. Now, interestingly, if d squared, if I said PA squared then, let's do down here. So PA squared equals, and I can use the distance formula. It's gone silent. I'm hoping someone will help me out here. So decide which one's going to be x2 and which one's going to be x1. So P is going to be x2. So you're going to have x minus 3. Yeah? All squared. Plus y minus 1. All squared. You happy with that? Everyone happy with that? All right. What's the other one going to be? Or do you want to expand that one out first? Should we expand that one out first? Probably expand that one out first. Okay. So what are you going to get? Remember that becomes a plus. The x minus 3 becomes x plus 3. I'm assuming you said 6x, not 3x. Square the first, square the last, double the product. Yeah? So that's a perfect square, just expanded. And then what do we get on the y one? Y squared. Close. Double the product. Square the last. Plus 1. Okay, so that's expanded out. Now, we can simplify that by getting rid of the, you've got plus 9 plus 1. So that's x squared plus 6x plus y squared minus 2y plus 10. Cool? Now we've only done one distance, right? We've only done the distance. We have worked out the distance between A and P. Is everyone happy with that? That's what we've done. Cool? I'm now going to pause it and we'll start a new one because we're running out of time on this one. And what we're going to do is we're going to find the distance between P and B. Yeah? Everyone happy with that? Excellent.